Okay, so welcome to class. I do apologize that I'm not able to be there. However, I hope you understand. Um, I can't be away right now. We thought my wife was going to be released today, uh, and it turns out last night didn't go so well for her, so they're going to keep her longer. I'm dealing with it. I'll give you details if you're interested when I return. Hopefully next week, Thursday, same thing. We're going to be right here. This week, I can't leave her. Not going to happen. So here we go. I am going to share my screen. No, I'm not. I'm going to get my screen where it needs to be. Then I'm going to share my screen. All right. No. I guess my dogs and I, we are recording this. I'm recording this. And so I will be posting the video as well. So I usually post the class notes after class. I'm going to post the notes, and then I will also be posting the videos later today, and they'll all be on Blackboard. The video will be hosted on YouTube, but I'll make sure it's on Blackboard, at least the link, so it's easy for you to find. What else? I think that's it. Let's talk about section 7.4. 7.4 is permutations and combinations. And we are going to be using some calculators here. If you don't have a calculator, I'm going to give you a second to find one because I'm going to change our window slightly. We have a calculator right here, and I will be using it. But I want to use the other calculator as well at the same time. So I'm going to go about there. Yep, the dogs are home, so you'll get to hear them in all their wonderful full voice there. All right, so we're going to need a calculator. I'm going to keep this calculator up, but we're also going to come to the calculator that I have over on Google as well. Permutations and combinations. So we've talked about what's in a set and how many elements are in a set and how to find all of these different values. But what we haven't talked about is how we can like really kind of expand this idea. So here we go. A permutation of, hold on. If everybody could mute, that'd be awesome.
I don't have anyone right now. I don't know what you're talking about.
What?
Which Chris? Oh no, that kid does not exist in my head.
All right, we're good. Permutations, a permutation. Oh, I love online teaching. A permutation of n items is an ordered list of those items. So in order. So think of this, the closest example I could think about is Sunland Park Racetrack, right? Here's all the horses running and they have their positions, whatever. But when it comes to crossing the finish line, order matters, right? There's the horse that wins, the one that comes, what's called place, and the one that show. Just like in the Olympics, right? We have gold, we have silver, we have bronze. These orders matter. So why am I not writing right now? I don't know. I'm having a day. Order matters. Okay, order matters. The number of possible permutations of n items is given by n factorial. So factorial just means n factorial is n multiplied by every number less than it all the way down to 1. For example, 3 factorial is 3 times 2 times 1, which is 6. All right, so it's just that number multiplied by everything lower. For any positive integer n, we can't find a factorial of negative numbers. And it's been an agreement. I don't know who agreed to this, but it's defined that 0 factorial is equal to 1. So this is something we'll use frequently. Now, sometimes, so say there's, I don't know, 5 horses running in the next race at Sunland Park. 5 factorial will be the number of possible ways those horses can finish the race. Okay, that's what that is. Now, a permutation of n items taken R at a time is an ordered list of R items. I'm going to not underline that because the R is all messed up. Chosen from a set of n items. So it's a little bit differently. So this is, there are 8, no, there's not, because you can't write with an eraser. 8 horses. We want the top 3 winners. So n equals 8, R equals 3, and we'll use this formula, also known as NPR. We'll use this formula to calculate if there are 8 horses running in the Sunland Park Derby, and we want to find the top 3 ways that we can, the ordered list of the top winners, top 3 winners, we would use this to find out how many possibilities there are. Okay, now combinations changes it up a bit. Combinations is chaos, no order. Come on now. No order, chaos, or committees. Okay, is there a question? Selena, do you have a question? I'm going to mute you. I'm going to just randomly mute people so that I encourage you to mute. So my dogs provide enough of a background of. All right, so let's do a couple of these problems. I'm going to use black for our permutations. I'm going to use blue for our combinations. All right, so P of 12, 8. We are going to look at our formula. P of 12, 8 is 12 factorial over 12 minus 8 factorial. So we know that that's 12 factorial, right? 12 and every number multiplied below it. 12 minus 8, that's 4. So what we really have is we have 12 times 11 times 10 times 9 times 8 times everything, right? All the way down. And that's why we came up with a shorthand notation, this factorial, because nobody wants to write all those numbers. I actually just had to randomly check and make sure that I didn't skip anything. 4 factorial, that's easy. That's 4 times 3 times 2 times 1. All right, but check it out. Let's pull up a red here. This 4, 3, 2, 1 is going to cancel that 4, 3, 2, 1. And so this is really just 12 times 11, 10, 9, 8, 7, 6, and 5. And we can do that. We could type that into this calculator one by one. Ugh. And we can try to do it without messing up. And the only way I could do that was if I didn't talk while I did it. And we get a huge number. 199,584. All right, 19 million. That's huge. And I don't think WebAssign likes commas, so I probably shouldn't have put the commas in there. And that's fine. We can do that. But nobody wants to have to do that. So what we can also do is on our TI calculator, over here on math, PRB stands for probability. So we're going to arrow over. And right here it has an NPR. And that's not National Public Radio or whatever else NPR stands for these days. That is permutations. So what I should have done first was type in my 12. Then I go to math, over to probability. I'm using a permutation. And then I put in a 2. So I'm going to put in 18 NPR 2, enter. Don't put in 2 because it's an 8. We're not going to randomly change the problem here. Back up, make that an 8. And look how quickly we get that answer. I like it. I like a lot. But not all of you have this calculator. I'm going to show you a couple of other ways to do this. All right, so this is our TI-84. 18. I don't know why I did 18. I really screwed that one up, didn't I? 12. 8. I put it in the calculator, right? That's the important thing. Here on Googs, notice this, this factorial. So that's 12 factorial divided by 4 factorial. And we get the same answer. So you could do it that way. You could also do 12 factorial divided by, and then use parentheses, 12 minus 8 factorial. You don't even have to do that calculating the 4. You can just enter it into the calculator. I think it's called the TI 36XS. This is one of the best calculators for the money. Let me find a good version of it. No, we like the cheap one. This is one of the best versions of this calculator, and I want to show you. It has a button. Tap to zoom right here. Right where, ooh, come back. This PRB button. If you have the TI-30XS, the PRB button is going to be your friend to get you to the probability menus. So look for PRB, look for buttons that have maybe an NCR over top of them, or NPR, depending on, come on, which calculator you're looking at. All right, make this go back. Make that go back. I don't know where. Let's bring this back here. All right, so there's many different ways to do it on a calculator. And for that reason, I don't do this very often because it's kind of a pain in the butt. But I'm going to do it one more time because I'm going to do it for our C formula. So when I have C of 9,6 using our formula, well, that's a weird looking formula, but we're going to use this version of it. We have 9 factorial divided by 6 factorial times 9 minus 6 factorial. So that is 9 factorial divided by 6 factorial, 3 factorial. Now I'm going to do this one out by hand so that we could see exactly what's going on here. I do a lot of examples by hand in the video, in the full video lecture. So check those out too. Remember, those are always a good source because I talk about different examples there. And they're not the same as examples that's in the book. So you get a whole bunch of variety. A 9 factorial, 6 factorial times 3 factorial. And check out what happens here. I'm going to take this big one, this 654,321, and I'm going to cancel it with this 654,321. Right? Numerator to denominator, we could cancel that. But look, we can also, this 3 goes into 9 3 times. This 2 goes into 8 4 times. So it looks to me like if I wanted to actually do this by hand, it's 3 times 4 times 7. 12 times 7 is 84. And what this says is if I have 9 students and I want to put 6 in a group, there's 84 different ways that I could do that. On a TI-84, we're going to put in the 9, NCR, and then 6. And remember that NPR, that NCR is found here in the math menu. So this will be 9, math menu, over to probability. This time I want the one with the C. And my R value is 6. Look at that, 84. So whether we do it by hand or do it by calculator, we're going to get the same answer. I could do 9 factorial divided by, I'm going to put a big parenthesis around my whole denominator, 6 factorial, 3 factorial, and I'm going to get 84. So whether you do this by hand, because you're used to doing work by hand, or you do this by TI-84 because that's what you use, or you just use any random calculator, you can do this in many, many different ways and you're still going to get the same number. Now, if all the problems were this, it'd be super easy, but of course they're not all problems like this. So we're going to look at keywords. Unordered. Unordered generally brings chaos, but it's also groups. Like if I just need 6 people in a group, that's different than I need the 6 people to be president, vice president, treasurer, secretary, sergeant at arms, and whatever else made up thing we're going to make, right? There's an actual job associated with each of those. But in a group, it's chaos. It's unordered. It doesn't matter. I have 5 items and I have 8. N is always the bigger value. So R is 5, N is 8. And I'm using chaos or groups. So this is a C. I'll use C of 8, 5. And if you're a calculator user, you're going to beat me to the answer because I'm going to do this out. 8 factorial over 5 factorial times 8 minus 5 factorial, 8765 factorial. I'm going to leave this as 5 factorial. Why am I going to write out all those numbers when I know they cancel anyway? And then this 3 factorial, right? 8 minus 5 is 3. Let's make it a highlighter. Using red. This 5 factorial cancels my 5 factorial. This 3, 2, 1, 3 times 2 times 1 makes 6. And so our answer for this is 56. And if you did that on the calculator, you got the same answer. But I want to show you something. All right, check this out. Right, this is unordered sets, 5 items chosen from 8. So I have 8 Halloween Starbursts left over, and I'm going to grab 5 of them at a time. All right. But what happens if I do, so I'm going to do 8 math probability NCR 5. All right, there's 56 different ways. But what if I had those same 8 and I had to choose 3 of them to give to someone else, right? What's the difference between having 8 and I'm going to keep 5 of them, or I have 8 and I give 3 of them away? There's no difference whatsoever. Whether you keep 5 or you toss 3, you're doing the exact same operation. So with C, there's some interesting things going on because there's a couple of different things going on here. So we got to watch for that. It's never going to trip you up. The numbers they give you, you don't have to like overthink it. This was an extension. And in this extension, notice I didn't write anything down because it's not something you need to mathematically remember. Just, hey, that's kind of cool. I know it's math. I've been home alone too long, far too long. All right, I haven't saved in a minute. I know it's saving automatically, but let's hurry that up. So how many 4-letter sequences? Come on. Yeah, I just want black. Sequences have order. And if we have order, we use P. We want these letters once each. So we have 4 letters. And we use 4 letters. This will be NPR. We have 4 and we want 4. We have P of 4, 4. That is so not right, people. It's 24. Here's why it's 24. Let's not overextend ourselves. I mean, that's not right. So we're definitely going to take that off of the notes so that people that don't look at the video don't know that I screwed that up. We have 4 letters. When we're placing the first letter, we have 4 options. When we're placing the second letter, we've already used 1, so we have 3 options. We have 2 options, and we have 1 option. This is 4 factorial. It's just, I have 4 items. Still up outside. That's my dog. Yeah, she's spoiled, and that's why she barks as any naughty girl. So we just have 4 factorial. There's 4 times 3 times 2 times 1 permutations. All right, so we are using permutations, but we're taking all of them. So we multiply all the way down. Just like we had in those bits in the terabytes, terabytes, I don't remember what the words were, but we had digits 0 and 1 or 0 and 1 and 2. It's a lot like that. All right. Your international diplomacy trip requires stops in Thailand, Singapore, Hong Kong, and Bali. How many possible itineraries are there in which Thailand is the last stop? Okay, so an itinerary is all about organization, and it has order to it, right? It matters what country you go to first because, I don't know, you're connecting airplane from where do I want to go? I don't know, from Argentina. Oh yeah, I forgot the names right here. I'm not okay, guys. My memory, like if I could start this whole lecture over, I totally would. I'm sorry. Hang with me. Let me reboot with some tea. If your connecting flight goes from Thailand to Singapore, but your itinerary says you're going from Thailand to Bali, you're not going to be ready for the weather in Singapore or for what the notes for the meeting you need in Singapore if your plane's taking you somewhere else. So order matters. So we use permutations. So we have Thailand, Singapore, Hong Kong, and Bali. I want the last stop to be Thailand. So that means I have 3 options for the first stop. It could be any of these 3. Once I choose one, now I have 2 options for the next stop. And then there's only one place to go because Thailand has to happen. 3 times 2 times 1 makes 6 itineraries. All right, Thailand is forced. So there's only 3 options, Singapore, Hong Kong, or Bali. Once we go somewhere first, there's only 2 places left that we could go, Hong Kong or Bali, let's suppose. And once I've gone 2 places and I know Thailand's last, there's only one place I could go as my third stop. I was going to do, yes, I think it's number 9. It's not number 9, it's number 11. Number 11 doesn't make this last stop Thailand. If we take a look at it, I'm going to pull it up here. How many possible Okay, we have 1, 2, 3, 4, 5 places. Order matters. There's no restrictions, right? So it doesn't matter. So on for me, for number 11, we have 5 places. Order matters, but no set stops like number 10. So 5 places, I'm going to end up with 5 factorial. All right, so that would be my answer for this one. And I'm going to put in these answers because, you know, I don't get points for my homework very often. 6 and 5 factorial. 1 times 2 is 2, times 3 is 6, times 4 is 24, times 5 is 96. That doesn't seem right. 20, 60. I can't calculate. I didn't like 60. What? Let's make sure that one's right. Is this 120? 20 times 3 is 60 times 2. All right. My bad. I was right. Just my brain was not right. Oh, look at that. Okay, so we're going to work on numbers. I'm going to come back here. I'm going to make this happen. We're going to do a number 9 and 12 together, although I'm looking at number 12 and I might just take it off entirely. Here we go. Click to begin. This is going to be my scratch work for number 9. We wish to determine the number of 4-letter sequences. So as I'm looking at this, I'm looking at sequences. Requires order. So I'm going to be using permutations. Possible if the letters D, L, M, T, and V. D, L, M, T, V are the only choices, and if each letter is used at most once. Very important there. A 4-letter sequence such as DLMT would be one sequence, while different orderings of the same 4 letters, DMTL, DTLM, etc., would be counted as entirely different 4-letter sequences. So if I wanted to know, like, okay, I'm going to write down all possible 4-letter sequences with these 5 options, I want to know when I've listed them all. And these permutations allow us to check that. Different orderings of the same 4 letters. So what do we have? We have 5 letters. What are we going to use? We're going to use 4 letters. Went British. Whatever. Okay. So the order in which the letters are picked matters. Okay, so the order matters. Well, that wasn't so hard. I love having to submit every time. Since the order that the letters are picked matters, the number of possible sequence can be counted using a permutation. Recall that a permutation is that, yep. The possible letters D, L, M, T, and V, and we wish to form a 4-letter sequence. Therefore, we must calculate a permutation of what we have: 5 items taken 4 at a time. All right, so what we have and what is taken, what we use, is the 4 letters. In other words, this is P of 5, 4. All right. Next step, we have the formula for this. So let's see if we could fill in the blanks. They've already put the 5 in for N, so we must have a 4 here for R. But we all know that 5 minus 4 is 1. It already has the factorial for me, so we're good. 5 factorial divided by 1 factorial. And this is where I'm going to use some of my paper here. 5 factorial over 5 minus 4 factorial. Denominator of 1's kind of boring, and we just did this one. 5 times 4 is 20, times 3 is 60, times 2 is 120. So that means there are 120 possible 4-letter sequences described in this problem. So if you were trying to list these, DLMTV, taken 4 at a time, you would have 120 things to list. That's a lot more than just like flipping a coin twice, right? Or flipping 2 different coins. Coins and dice, we could list them because it's a limited number. But when we start getting into more things, instead of just taking them 2 at a time, we take multiples. Now we have to start counting without being able to write them all down. And it gets a little challenging at times. All right, but that one's not too bad. I like that one. So let's see if we could handle number 12. I don't want to handle. Okay, here we go. I'm not going to be whiny. I have a 16-year-old. I get enough of that at home. All right, just kidding. Not really. A poker hand consists of 5 cards from a standard deck of 52. Find the number of different poker hands of the specified type. Okay. We have 52 cards. And we want 5. All right, that's a 2. 52, and we want 5. Okay. So we're looking for 2 pairs. So 2 cards of one denomination, 2 of one denomination, 2 of another denomination, and 1 of a third. So for example, we might have a 2, a 2, a 3, a 3, and a 4. So same number. These 2 have to be same number. These 2 have to be the same number. And this one has to be different. But these 2 can't be the same number, right? We can't have 2s and 2s. Can't have 2 pair of 2s. That's 4 of a kind. So there's some stuff going on, some like seriously weird things. Okay, for those of you unfamiliar with playing cards, there are 4 suits. There's hearts, diamonds, clubs, and spades. 2 of those suits are red, hearts and diamonds. 2 of those suits are black, clubs and spades. All of the suits have the same cards from ace. Ace is like a 1 generally. Ace it's also a high card. It depends on the game you're playing where ace is. I think of it as a 1 as they have it here. Number cards 2 through 10. And then the jack has a picture of a jack on it. Queen has a picture of a queen on it, and the king has a picture of a king on it. So these are called face cards because they have pictures of people. And if you've played with cards before and you know this, you're like, Tuesday, why are you wasting our time? But there are a surprising number of people who have never really seen a deck of cards or played with them. And it blows my mind. So I want to make sure everybody understands what's going on here. All right, let's do it. Recall the entire deck. The goal is to determine the number of different 5-card poker hands that consists of 2 pairs. In other words, we need to find the number of ways to pick 2 cards of one denomination, 2 cards of another denomination, and a final card that belongs to neither the first of the 2 denominations, right? As I laid out here. So our decision algorithm has 4 steps. Remember, with each step, since it's a sequence of steps, we're going to multiply the outcomes of each of these steps. So I'm going to put step 1, step 2, step 3, and step 4. Okay, we begin with step 1. Select 2 denominations for the pairs. There are 13 possible card denominations, right? 1 through 10, 11, 12, 13. 13 possible denominations. I'm going to write this here. We have 13 denominations, values. We have 4 suits, 52 cards, 4 suits, 13. Yeah, I think that's enough. I think that's all we need. Suits are just the decoration. All right, so 13 possible values, and we want to pick 2 of them. The order that we make this selection does not matter. It doesn't matter if we get 2s first or 3s first. It doesn't matter. We're going to use combinations to find the number of ways to pick 2 denominations out of 13. So for step 1, we'll have C of 13, comma 2. 13 values. We want to pick 2 of them. All right, so this is step 1, picking 2s. Step 1, picking 2s and 3s. All right, to fill it in, the N value is 13. 13, comma 2, if I do the calculations, fantastic, I have a 13 factorial over 13 minus 2 factorial times 2 factorial. 13 minus 2 is 11. This is 13 times 12 times 11 factorial. This is 11 factorial times 2 factorial. But remember, I wrote them as factorials because I was too lazy to write all the digits because they cancel out. And we'll end up with 13 times 12, 6 goes into there. Head hurts, 144, 156 divided by 2. Nope. Nope. Let's calculate this. 13. Math. 13, comma 2. We get 78. Yeah, I was not even close. Oh yeah, 156, half of it. I was there. I was there. All right, so step 1 is 78. Whew, that was rougher than we needed there. And in other words, there are 78 possible ways to pick 2 of the 13 denominations for the pairs. All right, so out of the 13 different values, we want 2. We want 2s and 3s for my example. We have 2 values. Awesome, everything's good. We now move on to steps 2 and 3. Step 1, select 2 denominations, 78 possible ways. Step 2, select 2 cards from 1 selected denomination. The 2 denominations have been selected. How many different cards of each denomination? So how many 2s are there? For step 2, I'm looking at how many 2s. There are 4 suits. So 4 2 denominations. All right, so there's 4 of each value, right? 4 2s. 4 cards of each denomination. Therefore, we're looking at C of 4, comma 2. And C of 4, comma 2. That's 4 factorial over 2 factorial, 2 factorial. That's 4 times 3 times 2 factorial over 2 factorial times 2 times 1. These 2 factorials cancel out. 4 times 3 is 12. 12 divided by 2 is 6. So we have 78 times 6, right? There's 6 different ways to pick 2 cards from one of the selected denominations, but there's also 6 ways to pick the other denomination. So 78 ways to pick two values. 6 ways to pick 2 twos from the deck, and 6 ways to pick 2 threes from the deck. So I've taken care of my 2 pairs. Now I need to deal with this 4. All right, so I've gotten my 2 pairs. I got 2 cards that are 2s. I got 2 different cards that are 3s. Now with step 4, let's submit this. Now with step 4, right, our last possible thing, we want to select one card that belongs to neither of the previously selected denominations. So this 4 doesn't have to be a 4. It just can't be a 2 and it can't be a 3. So, wow, what? We already took 4 cards out, right? These 4 cards. That's not true. How do I want to say this? All right, step 4. So we remove all 2s and all 3s because we can't use any 2s and we can't use any 3s. Total of 8 cards. All right, we know that this 5th card has to be different from our pairs. So we can't have any 2s, we can't have any 3s. All total, if we scroll up a little bit here, there's 8 total cards that we've taken out of the deck. 8 2s, or 4 2s and 4 3s. So 52 minus 8, in a good day, I could do that. 2, 6, 44 cards that we can pick from for the final card. So out of the 44 cards that are left, I need one of them. And there's only 44 ways to choose one card out of 44. We're almost done. We're so almost done. You're doing awesome. Finally, we calculate the total number of possible hands. Keep in mind, these are steps. And that's the multiplication principle, right? Steps. That's why we're multiplying these all together. There are 78 possible ways for step 1 to happen, 6 for step 2, 6 for step 3, and 44 for step 4. So I'm going to pull out a calculator and not even think about trying to do that in my head. 78 times 6 times 6 times 44. 123,552. There are 123,552 different ways that you can get 2 pairs with a standard deck of cards. And that, my friends, unfortunately, is going to be super important in chapter 8. So I'm glad we did this one all together. I'm glad I chose not to delete it. I really thought about deleting it. But it's actually super important in order to get a lot of the things that we're going to do in chapter 8. So what we're going to do in chapter 8 is, all right, so what are the chances of getting 2 pairs? Well, out of all these different options, you want one of those. Actually, no, that's not even true. We have to take this number, this 123, and then we're going to divide it by all possible poker hands. Just here's 52 cards. We want 5. That's going to be our denominator. And we're going to see that poker is like the worst odds ever. And people really shouldn't play it because you're never going to win money. You got to be lucky. You got to have a lot of money to invest. Okay. I've been talking a lot, y'all. Been saying y'all a lot too. How are we doing? Anybody have any questions? No. Okay, awesome. Does anybody have any questions on any other homework that they want to go over while I'm here? All right. Give this stuff a shot. You can do it. You got this. I will be on my office hours tomorrow from 2 to 3:30. I think there's an office hours link in the administration folder. I don't know. But it's there. I know it's there. Second thing, if you need it, just I guess email me before 2 o'clock tomorrow. No, you know what? I'm going to put the link for my office hours and WebAssign announcements. That seems like the most logical place, because where are you when you have a question? You're doing your homework. So I'll put the link in the WebAssign announcements. That's just genius. It took me this long to think about it. I've been teaching with WebAssign for I don't know how long now. Anyway, I'm going to post these notes just like I do every time. I'm going to stop this video. I'm not editing because I just don't have it in me to edit right now. And editing, no. I'm going to upload it to YouTube and then post it on Blackboard. So you don't have to go searching for it or anything. I'll post a link when it's ready. I just need to make sure that my captions are there. I want to make sure that they're available for everyone. And I kind of have mush mouth sometimes, so it's good to see my words on this screen. Thank you for being here. I'm really sorry I'm not there. Tomorrow being Thursday, I'm not going to be there either. Hopefully my wife gets out tomorrow. She had a rough night, so she's not getting out tonight. She was knocking on death's door on Friday. She had a heart rate of 20 and a blood pressure of 70/40 when I finally convinced her to go in, and it's been rough. I'm wrecked. I'm totally wrecked. But I will get your notes up for chapter 8 before class on Thursday is the best I could do right now. Looks like I'm going to have some time on my hands since she's not coming home tonight. So hopefully I'll get those done today. If there's anything else, let me know. I'm trying to keep up on my email too. It gets kind of backed up, and then I'll finish it. And then I'm doing the best I can. You do the best you can. Be good to each other, but mostly be good to yourselves. If you have nothing else, have a great day. Bye, Celino. Bye, Paula. Bye, everyone. Thank you very much, Alejandra or Aaliyah, whatever you prefer.